Welcome to our YouTube channel. This is Ernest coming to you from MathLab Tutorials in Toronto, Canada. Our mission impossible, as always, is simply to convert some of that math hate to math love. As your screen says, like it or not, math really did take us from the Flintstones era to the Jetsons era. No doubt about that. Now let's get down to some serious math. This will be video number 6 of the BEDMAS series, and we're going to continue dealing with fractions. And I know you guys love to hate fractions, but again, I indicate that they're a necessary evil. You must learn how to deal with them. Otherwise, your math career is going to be very limited. Okay, so anyway, let's look at Q1. It says use BEDMAS to simplify the following fraction string. And if we take a bird's eye view of this problem over here, we'll look at this expression. The first thing I notice is that there's a dot. There's a set of brackets here, a set of brackets there. And over here we have a little fraction string, so we have to do a DMF. Over here we have a little fraction string, so we have to do a DMF. So again, we have one cluster, and we have to do a DMF here and a DMF here. When we do the DMF here, the DMF means do me first, we find that the LCD of 2 and 3 is 6. The lowest common denominator of 2 and 3 is 6. And the LCD of 2 and 4 is 4. So that's how we begin doing the DMFs. So we open up a set of brackets. Long fraction bar, put the LCD on the bottom. We can go to the other one, long fraction bar, put the LCD on the bottom. And then we deal with all the numerators. So we get a -1, drop it down, dot empty bin. +2, drop it down, dot empty bin. Over here we get 1, drop it down, empty bin. -1, drop it down, empty bin. And now our job is to fill in the bins. Of course, we always use the LCD to fill in the bins. 6 divided by 2 is 3, drop it in. 6 divided by 3 is 2, drop it in. 4 divided by 2 is 2, drop it in. And 4 divided by 4 is 1, drop it in. And now the idea is to simplify the numerators for each term. So that's what we'll be doing in the next step. Over here we have -1.3 is -3. 2.2 is 4. And of course all over 6. Over here 1.2 is 2. -1.1 is -1. All over 4. So you continue to simplify inside each set of brackets. After all, BEDMAS says you must simplify inside the brackets first. Over here we get a 4 minus 3, which is 1, so it becomes 1 over 6. 2 minus 1 is 1, so it becomes 1 over 4. Over here we see a dot, so in the next step, well, we do a neg count over here. The number of negatives is 0, so the result must be positive. Remember, when the neg count for a single cluster is even and 0 is even, then the result is positive. Okay, so in the next step, you're going to do a 1.1, which is 1.1, 6.4, which is 6.4, and then finally 1.1 is 1, and 6.4 is 24. The plus sign gets dropped as usual, and the final result over here, 1 over 24, is proper and irreducible. So that must mean we have the final answer at hand. Okay, let's go on to the next slide. This problem is a little bit more complicated, but we'll take it one step at a time. This is Q4. Again, we're going to be using BEDMAS with fractions. If you take a global view or a bird's eye view of this entire expression, the first thing you should notice are the dots in between the brackets. That indicates we have one cluster. The dot, this dot over here in between these two brackets, second cluster. The dot in between these two brackets, third cluster. The next thing you should realize is that the plus sign separates the first two clusters. The plus sign separates the last two clusters. And another thing you should notice is that this bracket requires a DMF. In other words, it requires simplification. And this bracket requires a DMF. Okay? Everything inside the other brackets are all ready to go. So they're all drop downs. So I indicate that with an arrow. You just drop it down. This is just complete drop down. That's a drop down. Over here with this DMF here, do me first. The LCD of 4 and 8 is 8. And over here, the LCD of 3 and 2 is 6. Okay, so 1/2 gets dropped down. Over here, because we're adding fractions, big division bar, LCD on the bottom, which is 8. And then we do a -3 dot empty bin, and then a +1 dot empty bin. And then we'll fill in the bins using the LCD. 8 divided by 4 is 2. Drop in the 2. Then 8 divided by 8 is 1. Drop in the 1. And the -3/4 dot 1/2 is just a complete drop down. All you do is drop the whole thing down. The 1/4 gets dropped down over here. Nothing to do. This over here requires some simplification using the LCD. Again, big division bar. Put the LCD on the bottom. And then you drop the numerators down. You do -2 dot empty bin, there it is, and then +1 dot empty bin. And then we have to fill in the empty bins as usual. And we do that using the LCD. We get 6 divided by 3 is 2, fill in the bin. 6 divided by 2 is 3, fill in the bin. And now it remains to simplify the numerator here and the numerator here, and we'll have to go to the next slide to do that. When we simplify those numerators, it becomes -6 plus 1, and then -4 plus 3. Everything else is just drop it down. Okay, so 1/2 gets dropped down. -6 plus 1 is -5. So we get -5/8. This whole cluster over here gets dropped down. -4 plus 3 is -1. So this becomes -1/6. And 1/4 gets dropped down. Now, again, we have the 3 clusters intact as usual. And over here we have dots in between. Therefore, we can do a neg count for each cluster. So we do one cluster at a time. The neg count over here is 1. There it is right there. The neg count over here is 1. There it is right there. The neg count for this one is 1. There it is right there. All 3 are 1s, and they're all, of course, odd. So each cluster is negative. We get a negative, negative, negative. So in the next line, we put the minus sign down, and we do the multiplication. Disregard all the negatives. Again, you put the minus sign down, you get a 1.5, which is 5, and 2.8, which is 16. And this cluster over here is negative, so drop the minus sign down. We get a 3.1, which is 3, and 4.2, which is 8. Again, this cluster is negative, so you bring the minus sign down, and we do a 1.1, which is 1, and 6.4, which is 24. We're getting there. Now we have a simple fraction string. We know how to deal with this. We've done many of these in the past. We see that the LCD of 16, 8, and 24 is in fact 48. So this LCD is a little bit more complicated, but with a little bit of thinking, you can figure out that the LCD is 48. Or if you've got a really good scientific calculator that'll do LCDs for you, You can let the calculator do the LCD, and it'll certainly come up with 48 as the LCD. So in the next line, big fraction bar right across. Put the LCD in the denominator as usual. And now we have to deal with all the numerators. You do a -5 dot empty bin, -3 dot empty bin, -1 dot empty bin. And now it's time to fill in the empty bins using the LCD. We do 48 divided by 16 is 3, fill in the bin. 48 divided by 8 is 6, fill in the bin. 48 divided by 24 is 2, fill in the bin. And we see the numerator over here will turn out to be an integer string. We get a -5.3, which is -15, -3.6, which is -18, -1.2, which is -2. The numerators here are all negative, so nobody's fighting. All we have to do is add all the numbers up. The result's going to be negative, so we put the negative sign there, and then 15 plus 18 plus 2 will give you 35. We notice that 35 over 18 is a proper fraction, but it's irreducible. There is no common divisor between 35 and 48, so we conclude that this is the final answer. Okay, let's go on to the next slide. Again, we're going to do more BEDMAS with fractions, but this time it will include division. So if you look at this carefully over here, the division sign between these two brackets over here indicates that we have a single cluster. Okay, but we have a DMF over here and a DMF over here. Why? Because we have a fraction string here and a fraction string here. So we have to perform the operation inside the brackets first, and those are LCD operations inside the brackets. So this, again, DMF means do me first. So you got to do the inside of the brackets first, the inside of the brackets first. We look at the denominators 2 and 3 and conclude that the LCD of 2 and 3 is 6, pretty easy to do. And the LCD of 2 and 4 is 4, easy as well. So in the next line, you drop the division symbol down and big fraction bar, put the LCD on the bottom. For the other one, big fraction bar, and put the LCD on the bottom. Now we'll deal with the numerators as usual. You put down -1 dot empty bin, there it is, plus 2 dot empty bin, there it is. And then we'll deal with the other one simultaneously. You do 1 dot empty bin, -1 dot empty bin. And now it's time to fill in the bins. Of course, we always use the LCD to fill in the bins. 6 divided by 2 is 3, fill in the bin. 6 divided by 3 is 2, fill in the bin. And 4 divided by 2 is 2, fill in the bin. And 4 divided by 4 is 1, fill in the bin. And then this fraction over here is going to have an integer string on top, basically. And this is going to have an integer string on top as well. So those integer strings need to be simplified a little bit further. Over here we get a -1.3, which is -3, and 2.2, which is 4. And of course the 6 is the LCD, which we drop down. Over here 1.2, which is 2, -1.1, which is -1. And again, we continue to simplify inside the brackets. Over here, -3 plus 4 is 1, and 2 minus 1 is 1. So now everything's completely simplified except we have a division symbol. If we do a neg count over here, we get a neg count of 0. That implies that the final result is positive. And because we have a division over here, we have to do a keep dot flip. Okay, so you put the plus sign over here indicating that the result is positive. Why? Because the neg count was 0. And you keep the first fraction as 1/6. the division symbol gets replaced by a dot, and you flip the second fraction, which is 4 over 1. At the end, you do some multiplication, 1.4, which is 4, and 6.1, which is 6. So you get plus 4 over 6. This reduces to 2 over 3 by dividing top and bottom by 2. Of course, we can drop the plus sign at the end, as usual. And 2 over 3 is a proper fraction, and it's irreducible. And so that would be the final answer. Let's go on to the next slide. Question 8. Oh, substantially harder, but we can handle it. Okay, you just have to take it one step at a time. Don't get overwhelmed. The whole idea is that math is very, very procedural, and you have to get the process down pat in order to achieve good results. One false move at any step in the procedure, of course, is going to cause a catastrophe at the end. So you've got to be very careful as you go. And that's why they say that practice makes perfect. That's the only way you can perfect something, is by practicing what you're learning. Okay? Because you're going to encounter all sorts of situations in math, especially higher level math. And this BEDMAS stuff that we're doing right now is going to have to become second nature if you decide to go into something like engineering or physics or even math for economics, or any of the number of sciences that will involve mathematics at a higher level. So do me a favor, do yourself a favor, learn how to deal with this now by practicing. Anyway, the sermon is over. Let's go ahead and do this. If you look at this carefully, again, a bird's eye view. Division symbol means that this is a single cluster. Division symbol, single cluster. Division symbol, single cluster. Plus sign separates these two clusters, and then a plus sign separates these two clusters. If we look more carefully now inside the brackets, this has already been simplified. It's done. It's good to go. So it becomes a drop down. This over here requires a do me first. It requires a DMF. We have a little fraction string here. The minus 3/4, somebody's already done it for you. And the 1/2, somebody's already done it. So your best bet is to drop this cluster down as a block, and don't do anything with it until we're ready to do some more operations with it. This over here is a little fraction string, so it's a DMF, and we're going to use the LCD to simplify that. And the 1/4 is just a drop down. Okay, so again, we identify 3 clusters, and we need to simplify each DMF first. Everything else, aside from the DMFs, is just a simple drop down. Okay, so drop downs are indicated by these arrows over here. Just drop it down to the next step. 1/2 drop down, division bar drop, or the division symbol drop down, and we're going to do this DMF over here. Fraction string, the LCD of 4 and 8 is 8, so we need a big fraction bar. Put the LCD on the bottom, and then we'll deal with the numerators as usual. You do a -3 dot empty bin, there it is, and then a +1 dot empty bin, there it is. Let's fill in the bins. We have 8 divided by 4 is 2, fill it in. 8 divided by 8 is 1, fill it in. Let's go on to the next one. Okay, there's nothing to do over here, so just leave it alone. And this one over here, we're doing an LCD. The LCD of 3 and 2 is 6. So big fraction bar over here, put a 6 on the bottom. And of course, the 1/4 is just a drop down. And we're going to have to deal with the numerators again. And you do -2 dot empty bin, and then +1 dot empty bin. And again, we have to fill in the bins using the LCD. 6 divided by 3 is 2, fill in the bin. 6 divided by 2 is 3, fill in the bin. So slowly but surely we're getting there. Okay, but it's very procedural. Let's go on to the next slide to finish this problem off. When we simplify that integer string in the numerator, we get minus 6 plus 1. And the other integer string will give us minus 4 plus 3. Again, everything gets dropped down. 1/2 gets dropped down. 1 minus 6 is minus 5. So we get minus 5 over 8. This whole block over here, this cluster gets dropped down. And over here, minus 4 plus 3 is negative 1. So we get minus 1 over 6. Drop it down. Division sign, drop it down. The 1/4, drop it down. Now it's time over here to do some neg counts, because we have a cluster here, a cluster here, a cluster here. So we can do a neg count for each cluster. Over here we count 1 negative, put it down. We count 1 negative over here, put it down. Over here we count 1 negative, put it down. So for all the neg counts we get 1, 1, 1. So the clusters are negative, negative, negative. And then after putting down the signs, we can do a keep dot flip 3 times on the fly, so we don't waste any time. So this is negative. The 1/2 gets dropped down. That's the keep. The division becomes multiplication, and this gets flipped, becomes 8 over 5. Again, this cluster is negative. Drop it down. 3/4 is kept, so you keep the 3 over 4. The division symbol becomes a dot, and the second fraction gets flipped. This cluster is negative. The 1 over 6 you keep. The division symbol becomes a dot, and you flip the second fraction to get 4 over 1. And we're almost there. All we have to do is multiplications, and we're almost there. When we do the multiplications, we get minus 8 over 10, minus 6 over 4, minus 4 over 6. You know how to do all those multiplications because we've done them many times in previous problems. And then what you want to do at this point is reduce on the fly. 8 over 10 reduces to 4 over 5. I'll let you figure out how to do that. 6 over 4 reduces to 3 over 2. And 4 over 6 reduces to 2 over 3. Really important to reduce the fractions before you deal with the fraction string, because otherwise the LCD is going to get out of hand. You're going to have to do the LCD of 10, 4, and 6. Otherwise, it'll still work, but there's a lot more work involved. So it's key to keep the fractions reduced whenever possible before you do the LCD part. Okay, because if you don't, you're going to have large LCDs to deal with, and they're going to be that much harder to find. So I don't encourage that. Always reduce first before simplifying the fraction string using the lowest common denominator. If we look at this fraction string, the LCD of 5, 2, and 3 is 30, easy to find. And then at the end, we have a big fraction bar there. We put the LCD on the bottom as usual. And then we have to deal with the numerators. So as usual, we put a minus 4 dot empty bin, minus 3 dot empty bin. There's the empty bin right there. And minus 2 dot empty bin. And now we have to fill in the bins. And we use the LCD to fill in the bins. Now 30 divided by 5 is 6, fill in the bin. 30 divided by 2 is 15, fill in the bin. 30 divided by 3 is 10, fill in the bin. And as usual, we're going to get basically an integer string in the numerator. There, we know how to simplify. We've done enough of these now. We get a minus 4 dot 6, which is negative 24. Minus 3 dot 15, which is minus 45. Minus 2 dot 10, which is minus 20. They're all negative, so nobody's fighting here. The final result is going to be negative because the negatives, you know, they're only bad guys over here. There are no good guys, so nobody's fighting. So the result has to be negative. And then you just add all the numerators together to give you 89. And then you'll notice that 89 over 30 is improper and it's irreducible. It has no common divisors. So the most you could do at this point is either leave it as minus 89 over 30, or you can convert it to a mixed fraction. You'll notice that 30 goes into 89 twice, and then it's got 29 as remainder. So the final answer would be minus 2, and 29 over 30 would be the equivalent mixed fraction of minus 89 over 30. So the final answer could be either left as an improper fraction as minus 89 over 30, which is what I prefer, or you can leave it as a mixed fraction, minus 2 over 29, minus 2 and 29 over 30, which I don't like because it's hard to deal with if you were to perform subsequent operations with that mixed fraction. Okay, so let's go on to the next slide. Let's see what we're dealing with. Oh, exponent tidbits. We'll leave that for another video. Okay, so thanks to all for viewing this video. Stay tuned for many more videos to come. If you liked the video, please give us a like and subscribe to our channel. If not, tell us how to improve it. Over and out from MATLAB Tutorials in Toronto.